Everyone, here's something which we all found quite difficult yesterday, so I'm just going over it quickly. Identifying parallel lines on a coordinate grid when lines are diagonal. We were all fine with finding parallel lines when they were straight up and down, vertical, or straight across, horizontal, but when they're diagonal, we found it quite difficult. So I've started here with two lines that I think we all agree are parallel, but we're going to look at how we can use maths to show that these are parallel. So yesterday we looked at, well, if we extend these lines forever in both directions, they'll never get closer together or further apart, and of course this means that the lines are parallel. So if I drew these lines to go on in both directions forever, then they would never meet, they would never get further away, and therefore they're parallel, or these kind of train track effect lines. And of course it's nice and easy when you get lines like that because you can see straight away that they're obviously parallel. And sometimes in maths that's difficult because we don't think about why something happens, we just say, oh, well, it's obvious. But when it comes to things that aren't obvious, we then don't have any way of finding the answer. So I'm going to look at another reason why these lines are parallel. So let's look at the journey these lines take. And some of you guys did this last week, so again, we're building on prior maths. If I want to go from B to A, I need to go down 2 spaces and left 2 spaces. And if I want to go from D to C, I'm doing the same, down 2 spaces, left 2 spaces. And what this means is that, and this is a new word, the lines are the same gradient. And the gradient means how steep a line is. Now, as you know, Edinburgh is a very hilly city. If you walk up Arthur's Seat, at times the gradient of that hill is quite steep. Other times, you might be on a lower down bit and the gradient is not so steep. So the gradient is how steep a line or a journey is. And if two lines have exactly the same gradient, then that means they're parallel, because if they're the same steepness, then when you draw them on the grid, they're never going to get closer together or further apart. If they're not the same steepness, if one's slightly steeper, the other's slightly not as steep, then eventually they'll meet. They'll get closer together, so they're not parallel. So whenever we see two lines, we can find the gradient and we can see if those lines are parallel or not, depending on whether they have the same gradient or not. So here, I've got a journey from A to B of along 2 and up 3. Obviously the other way around, I could describe the journey from B to A as being down 3 and along 2. And from C to D, again, I go along 2 and up 3. So because I go along 2 and up 3, even though these lines are at quite different parts of the grid, they're not side by side, it doesn't matter. They go along and up by the same amount, so they're both as steep as the other, so they have the same gradient. And that means that these lines are parallel. So let's look at some more tricky examples like the ones in the quiz yesterday that a lot of you found very challenging. There's a line from A to B and a line from C to D, and it's not immediately obvious which of these is parallel and not parallel. So I've got from A to B, I go along 1 and I go up 7. From C to D, and I could use the numbers at the side of the grid to help me, which is where we get into using coordinates, I go along 1 and up 6. And so going along by 1 and up by 7 is not the same as going along by 1 and up by 6. The line from A to B goes up more quickly. I go along by 1, I go up by 7. That's a quicker way up than going along by 1 and up by 6. And because of that, the lines don't have the same gradient. One line, the left-hand line, is steeper than the other, and so they don't have the same gradient, so they're not parallel. Now, if we wanted to draw the lines until they did meet, we'd have to zoom out because they wouldn't meet until way down in the bottom left there, round about -50, -300. There is a maths way, using very advanced maths, when you see two lines to work out exactly where they meet, but that's not something that you would be doing just now. But the important thing to think about is that sometimes two non-parallel lines don't meet for a long time. So saying, oh, anytime I see two lines, I'll just draw them until they meet, and if they meet, they're parallel, and if they don't meet, they're not parallel. That's not a good strategy, which is why learning about the gradient is quite important. So a wee challenge question for you now. Pause the video if you like and think about whether these two lines are parallel or not parallel. Okay, so you might think that they are, you might think that they're not. One of the reasons that you might think that they're not is because they're both different lengths. Remember the other day, guys, the length of a line doesn't affect whether it's parallel or not. We can have one short line and one long line. They can still be parallel if they've got the same gradient. So B to A, down 1 along 4. D to C, down 2 along 8. So we might look at that and say, well, that's not parallel because they have a different journey. One goes down 1 and along 4, the other goes down 2 and along 8. However, if I think about that journey, down 1 and along 4, from D to C, I can go down 1 along 4, down 1 and along 4. So even though the journey is down 2 and along 8, if I break that journey down, then it goes down 1 along 4, down 1 along 4. So it's still a journey of 2 to 8, but it's being made using the same gradient as the journey of down 1 and along 4. Because I can see that every time I go down 1 along 4, I get to join up with the line again. So it's exactly as steep, so even though they're different lengths, these lines have the same gradient. So to look at another quick example, are these lines BA and DC parallel or not parallel? Pause the video and have a think. So let's look at the gradient of the two lines. So to get from B to A, we can go down 2 steps and along 3. If we try and do that to get from D to C, let's watch what happens. Down 2 and right 3, down 2, but this time if we want to reach the line again, we have to go along 4. So down 2, right 3, down 2, right 4. Now if we start having to go 4 spaces to the right instead of 3, every time we go down by 2 spaces, then it's not the same pattern. So in the first line from B to A, we went down by 2 and right by 3. If we try that with the second line, that doesn't allow us to keep up with the line. If I go down by 2, right by 3, down by 2, right by 3, I start to not keep up with the line. So they don't have the same pattern. One's going down slightly faster than the other, slightly steeper slope. So because of that, they don't have the same gradient, so they're not parallel. So today's learning is all about understanding that if we know how steep a line is, we can work out if it's parallel with another line. And if two lines are exactly the same steepness, the same gradient as each other because they go down and along by the same rate or the same ratio, to use a maths word, then they're parallel. If they're not as steep as the other, one goes down more quickly or one goes down more slowly than the other, then they're not parallel. Just to finish up with the challenge, pause this video here. I'm not going to give you the answer to this one, you can just have a think about it yourself. Based on what you've done so far, can you work out if these lines here are parallel or not parallel? Not easy to tell this just by looking at the lines, so you'll have to use the maths that you've just learned to work this out. If you want to leave an answer on Teams, feel free to do so and enjoy the day's activities.